Hi, good evening everyone. Here I am going to revise the fourth chapter, that is flew through the pipes. Already we have completed in the classroom. For the semester purpose, I am going to revise this chapter. Here the subtopic is minor and major losses in pipe flow. On the completion of this class, I am going to explain what do you mean by major losses and minor losses. What are the formulas we may use for the calculation of the major losses and minor losses. So generally in the pipes we may see the different types of energy losses. Those may be major losses and minor losses. So the minor losses, when we call as a minor losses, so generally the minor losses are obtained due to the change of velocity in the pipe flow. Means it may be obtained due to the minor losses mainly caused due to change of velocity. That is, the change of velocity may be occurs due to the direction of the flow, change of direction of the flow, or by the using of different types of different dia of the pipes. So due to that we may have different velocities in a pipes. So due to that we may obtain the different head losses. Those head losses called minor losses. So the minor losses are calculated by the using of Chezy's formula. Already we derived in the previous class. So that is Chezy's formula, that is V is equal C into root mi. By the using of this formula you may calculate the minor losses. So you may see here, due to the change in velocity of the liquid or the direction of the change in pipes. So major losses, generally the major losses are occurs due to the friction. So these losses are calculated by the Darcy's Weisbach equation. So that is an empirical formula. HF is equal HF is equal 4F LV squared by 2GD. So that is F is equal friction, loss of it due here HF is the loss of it due to friction, F is the coefficient of friction, L is the length of the pipe, here V is the mean velocity of the flow, and D is the diameter of the pipe. Whereas minor losses are calculated by the Chezy's formula. So that is V is equal to C into root mi. Here C is the constant, Chezy's constant, m is the hydraulic mean depth, I is the loss of head per unit length. Here you can see that m is equal again A by P. So A is the cross sectional area, P is the wetted perimeter, and I is equal HF by L. So minor losses, we may observe the different types of minor losses. Those are due to entrance of a pipe or exit of a pipe, or due to sudden expansion of pipe and sudden contraction of pipe, bend in pipe, and pipes fittings and obstruction in a pipe. All these are comes under the minor losses. So you may have formulas for the different head losses. So here loss of head at the entrance of a pipe, it is denoted with HI. So that is 0.5 V square by 2G. Already all these formulas are derived in the classroom. So here head loss due to head loss at the entrance of a pipe, here you can get HI is equal 0.V square by 2G, where V is the mean velocity of a pipe. So here loss of head at the exit of a pipe, it is denoted with H naught. So here H naught is equal to V square by 2G. Here V is the velocity at the outlet of a pipe. Whereas loss of head due to the sudden enlargement, here we may see the figure. Here we may see in the figure. So that is, this is the cross section 1, this is the cross section 2. Here we may see the sudden enlargement in a pipe. So loss of it due to sudden enlargement, it is denoted with HE. So HE is equal V1 minus V2 whole square by 2G. Here V1 is the velocity at the inlet, V2 is the velocity at the outlet of a pipe. Here loss of head due to the sudden contraction. We may see the figure. This is the cross section 1 this is the cross section 2. Here we may obtain the sudden contraction in a pipe. So loss of head due to the sudden contraction, it is denoted with HC. So the formula becomes 0.v square V2 square by 2G. So here V2 is the velocity of flow at the cross section 2. So thank you everyone. All these formulas are basic formulas. So by the using of these formulas, we may calculate the head losses in a pipes. So thank you everyone.